Morning everyone. So today's lecture is about micro lens. It is another application for MOEMS technology. So optical lens designs are based on refraction phenomena. All of you have studied that what is the meaning of refraction, that when a light ray passes from one medium to another medium, then the sign of incident angle to the sign of refractive angle is equals to the refractive index. The light gets diverted by some angle. Lens is used to focus the incident light beams. Micro lens, as the name suggests, it is a micro optical electromechanical device, does the same thing, that it focuses the incident light beams when it is used in micro devices. This focusing device is applicable for light beam aligning and optical signal sensing. The micro lenses could be a part of a micro system. An example of micro system is a micro XY stage called micro positioning system. Mainly when you have seen global positioning system. So similarly, this micro positioning system which take care for X and Y coordinates, and if it is working with the help of optical lens, then it utilize micro lens as one of the technology. In many applications, arrays of micro lens are fabricated. Importantly, two types of micro lenses are used for various applications. First one is micro Fresnel lens and second one is micro spherical lens. Typically, dimension of these lenses are in the order of 100 to 300 micrometer dia. Focal length typically 1 to 3 mm in case of Fresnel type, and for a spherical type it is 220 to 50 micrometer diameter, and focal length typically 30 micrometer. So these are the images of micro Fresnel lens with diameter 50 micrometer, and the figure B shows out of plane freestanding micro Fresnel lens. So Fresnel lens is flat on one side and rigid on the other side. UV lithography and reactive ion etching techniques are used for fabrication. Already in previous lectures we have studied that what is UV lithography and reactive ion etching process, which we generally use in case of microfabrication. So you all are aware with this information. The same technologies are applied. Now Fresnel lens consists of an array of polysilicon circular rings increasing in width and spacing towards the center, as you can see in this image number 8. Since surface micromachining processes cannot fabricate curved refractive lens, the Fresnel lens is the obvious choice. The lens has a plate called lens plate, which is having such feature like it is porous and lightweight. The lens plate is usually hinged so that it can be flipped up into the light path. A slider integrated with actuator lifts the plate, as shown in this figure number 2. These two are the sliders which can lift the plate up and down as per the adjustment required for the incident light path. The Fresnel lens can also be used to collimate laser light from laser diode. It is another application of this Fresnel lens. Micro Fresnel lenses are designed by employing binary optics theory. Now, binary optics theory is based on diffraction theory. But diffraction theory is more compatible to micro-optical components, while conventional lenses uses the principle of refraction, require design parameter in order of several millimeter of material. The binary optics technology employing diffractive effects that necessitates a fraction of a wavelength in size, facilitating the fabrication with micro dimension and depth as shallow as half a micron or even a nanometer order. So this is a basic difference in case of conventional lenses and the micro Fresnel lens, which is designed with the help of binary optics theory. Because in case of the conventional lens, the basic principle of refraction is used, which require design parameters of this quantity, that's several millimeters of material. But using the binary optics technology, it is possible that we can fabricate with micro dimensions and depth, and that is of the order of half a micron or even a nanometer order. So conventional optic lenses are polished to get the desired profile, but on the other hand, the binary optic technology uses high resolution lithography technique to transfer a binary surface pattern to the optical element. This is another difference between the conventional optic lens and the binary optic technology. So a question can be formed from this slide that how the micro Fresnel lens is different from the conventional lens. So we can explain that how the two lenses are fabricated and what are the difference between them. So binary optics is considered as a new technology capable of manufacturing thinner, lighter lenses and optical devices that were once impossible to make. The pattern is etched into a surface using ion beam etchers. This already we have covered that how ion beam process can be used for etching. A single etching step produces a two-level surface, justifying the name binary optics. Recently developed grayscale technology in MOEMS is an advanced technology using which a wide variety of surface profile and shapes with reasonably good optical performance can be achieved. So instead of using binary optics, we can also use a grayscale technology. Binary optics rely on a stair-step shaped approximation of the ideal surface shape. On the other hand, grayscale can create the smoother shapes, curves, ramps, toroids, or any other complex shape that is required. Now coming to the spherical lens, the microspherical lens is designed by a thermal reflow technique. This microspherical lens is also called microball lens. Two polymer layers are coated on a silicon substrate as shown in this figure number A. There is a substrate and a polyamide and a photoresist. The upper layer is essentially a photoresist from which the microspherical lens will be created, and the lower layer is a polyamide material. The hot air is blown over the two polymer layer. The method of blowing hot air is known as heat reflow process. So the main thing to understand that spherical lenses are fabricated or designed by the help of thermal reflow technique, in which the hot air is blown on the top layer of this photoresist material. When the upper polymer, that is the photoresist material, is heated beyond its glass transition temperature, the melting polymer will change into a spherical profile in order to minimize the surface energy. The interactive force between the material interfaces caused by surface tension makes it possible the upper profile to form a spherical shape. So this is a basic technique, that interactive force between the material interfaces caused by surface tension provides it a spherical shape. The polyimide form a pedestal, that is a base, to sustain the ball lens after the HRP is over. That means heat reflow process is over. The heat reflow process also forms the base polyimide into a trapezoid with arc side as shown in figure number B over here. That the sides are formed as a trapezoid to hold this arc shaped photoresistor lens. So in the next lecture, we'll start with the next application, that is micro mirrors. Thank you.